Okay. Can you see the recording?
Yes, ma'am.
Okay. Okay, good. So welcome all to the 24th lecture. I think there is some mistake in 24, 25 because we have had 2 classes on one day, but nevertheless, I'm just writing it as slide numbers, and you will see it, the classes updated on the course homepage. Sorry for the slight delay that has happened yesterday. Okay, so let's get to recursion. I hope you have tried out the examples in the lab yesterday. Those were designed for you to practice recursion, and hopefully they'll be helpful for you in today's lab, which will be a graded lab. We'll start at 2 o'clock as usual, and there will be 3 problems. What we are going to do is we are going to look at the problem of finding the largest. Once again, I want to bring out a few things. Even one of you has also asked me to do it. So we'll do that slowly and also run it on REPL and see some interesting aspects of the 2 different types of implementations of the program that we have written. Okay, before that, I want to ask, are there any other questions about the previous class or anything regarding lab or something that is not clear? Okay, so what I will do is I'll talk about this recursive finding the largest element in the array. We have seen 2 different ways of doing it. The first one was the way of thinking is just ignore the first element of the array for the moment. Find the largest in the remaining, that is 2 to n. I'm just indexing arrays from 1 to n for the moment, but find the maximum from 2 to n, and then compare it with the first element, compare the maximum with the first element, and return the larger of the 2. This is the first way of recursive thinking, which is written on the left hand side. There we said that there is another way of recursive thinking which divides the array into 2 parts, that is the left and the right. Remember, this is not a sorted array. If it is a sorted array, finding maximum is not at all difficult, because if it is sorted in the decreasing order, then it is simply the first element of the array or the last element if it is sorted in increasing order. So this is not a sorted array, but still we are saying that we can divide the array into 2 parts and find the largest of the left part, find the largest of the right part, compare the 2 and return the larger amongst them. So this is the second way of recursively formulating the problem. Okay, so Kaushal, were you saying something?
No, ma'am. It was on my.
Okay, sure. Okay, so what we are going to do is we are going to look at these implementations which are slightly, I mean, the ideas are exactly the same. The parameters for these 2 functions are going to be slightly different when I implement the recursive largest, but they are I mean, the main idea of the implementation is the same. So before I go to REPL, I wanted to ask, so Satyajit, you have specifically said that you want me to explain. So what is not clear? Can you explain what is not clear to you?
Like how the program is executed, ma'am. Logic is understood, ma'am.
Okay. So when you say how the program is executing, it's still not clear to me. Which one do you have difficulty? The left one or the right one?
If I understand the left one, it's enough, ma'am. I can understand.
Yes, I will explain it with a working example, Shashank, and I'm going to do that, but I want to understand what is the source of confusion so that I can emphasize on that when I look at the working example.
Like when you're telling the largest of I plus 1 comma n, like how are we comparing? After that, the if condition is checked or the function is returned to, like.
Okay, sure. So let us go to the implementations. Let us run them on explicit examples so that we see them in action, and then you can please ask me questions, stop me. So what I'm going to do is stop sharing the slide. Yes,
One small note, ma'am. In the first program, like if we give a value I and it goes inside the function, ma'am, once it encounters the statement L is equal to largest of I plus 1 comma n, will it directly go to the recursive, like will it directly repeat the function again, or will it finish off the if and else statement, ma'am? Like what will it do?
See, the program is executing step by step. So when you say L is equal to largest of I plus 1, it is going to call this recursive function, and a new function is going to get, new stack is going to get created for this invocation of largest of I plus 1 n. So this, only when this returns, this call returns, it is going to even execute this. But this largest of I plus 1 is going to call furthermore largest of I plus 2n, largest of I plus 3n, and so on, right? So this call will only return when the last call of the recursion ends, which returns to the penultimate one, which returns to its caller, and so on. And only when this returns, it is going to execute this if array of I is greater than L. Is that clear? But if it is not clear, we will look at the execution in a specific example. That may make things.
Just a minute, ma'am. So basically, we are just initializing L to the last element of the array, and then we are checking it, right? Like
No, we are not initializing L to the last element of the array. It is the largest of I plus 1 to n. So let us take a specific example of the array, array starting at, yeah, so the array, so this is
Ma'am,
passed from, yeah.
is I initially 2? I don't understand what I is, ma'am. What is
Okay, so
initially?
let us just okay, so let's just leave this exact implementation, go to REPL and see the exact implementation, and then we will run it on the visualizing environment where you should be able to see. So just give me a moment. I will change the sharing of the screen and we'll come to that. Okay. Yes. So Kaushal, can you see the browser now?
Yes, ma'am.
Okay, good. So yeah, and I hope you are able to see repl.it, right?
Yes, ma'am.
Okay, so let me just show you these two. Okay, so let's just take an array of size 8. Okay, so let us look at these two implementations. So I have called them two different ways, two different implementations. This is called as deep max. This function, is it readable, Kaushal, or is the font too small?
It is readable, ma'am.
Okay. Okay. So students, if you have any difficulties, please tell me. So this deep max is taking three parameters, the array. In the slides example, it is assumed that array is a global variable. So please, that can be changed, but this is taking an integer array. It is taking the start and the end as the two parameters, which are the indices into the array, and start is assumed to be less than or equal to n. So if start is equal to end, it is going to return array of start, which is the max element. Remember, we are not returning the index of the max element, but the max element itself. Else, we say that L, this is not 1, else L is equal to this. I'm again calling this function deep max. I will tell you why I have named it as deep max. Array start plus 1, end does not change. End remains the same. And that is what is n in that. N does not change. It will remain as the same thing. So this L is going to give us the maximum of the array starting at 2 to n, 2 to n minus, 1 to n minus 1 if you call it with 0 and n minus 1 to begin with. then it will call it with give the max of 1 to n minus 1. But this, how is this max of 1 to n minus 1 obtained? It itself is obtained using a deep max, which will call it for 2 to n minus 1. That itself is obtained for 3 to n minus 1 and so on. So this is how it is going to call. We are going to see the execution of this. And then if array of start, which could have been the maximum element, is greater than L, then we are going to return array of start, else we are going to return L. So is this code clear to everybody who, I mean, the people who are asking questions, or anybody? I mean, is there any doubt about this recursive way of implementing the maximum?
Ma'am, so the first value assigned to L is A of end.
The first value assigned to L is A of
End, because it'll keep going to deep max and finally when start becomes equal to end.
Yes, correct. That
Okay,
is
ma'am.
exactly, that is correct. That is the first time this returns, L will be assigned a value which is A of n. That will be considered as the max. Then you will look at, so let's take a concrete example of an array of size 8. So you will be calling it for, so I'm going to just write down on the right hand side. The first call is going to be for 0 up all the way up to 7. So the first time you are going to return L is equal to A of 7. That is what is going to be done. So the deepest recursion is going to, okay, so the call that is returning it is not 0 to 7. It is in fact 7 to 7, which is going to return the L is equal to A of 7. This will return to something which is 6 to 7. And at that time, it is going to check A of 6 and L, which is A of 7. And then it is going to return max of, I mean, this max is not deep max, it is simple max function, which is obtained by this 7 and 8. Line 7 and 8, one of them. So it will return either A of 6 or A of 7. And this will be the value of L. So this is going to be equal to L. Sorry, I'm writing it in a slightly weird way, but it is L. After this, it is going to return it to 5 to 7 call, where L will be one of A of 6 or A of 7. And then it is going to compare it with A of 5 and L. So it is going to return max of A of 5 and L, which is one of A of 6 and A of 7. And this continues. So is this clear to others also? Any questions? Okay, so assuming that this is clear, let us go to the second way of implementing this. The second way of implementing it also has the same parameters, that is array. It has the start and the end. However, it is dividing things into two parts. That is, it is dividing it into two parts, which is the array which is going from 0 to mid, the start to mid and mid plus 1 to end. It is finding the two maximums which are in the two parts respectively, and then it is going to return the max of the two, right? So as we did earlier, the shallow max, so let's say again we are looking at this array which is of size 8. So we are looking at an array which is indexed from 0 to 7. So the first call from main is going to be from for array 0, 7, where 0 is start and end is 7. Then we are going to go to 0 plus 7 by 2, which is 3. So because remember this is an integer, so therefore it is going to call shallow max of 0 dot dot 3. This itself is not satisfying the condition that start is equal to end. So it will find the mid of that. So 0 and 3, the mid is going to call it for 3. So it will be 0, 2. This will be the call that will be there. Finally, it will be 0, 1.
It should be 1 only, no? 0 to 1 only.
Sorry?
It should be 0 to 1 only, right?
Sorry. Yeah, I'm sorry. It is not 0 to 1. And then, thank you for pointing out. And then it will be 0, 0 finally, right? and at that point this is going to return. At this point it will return a of start is equal to the max. So this is the first that is being returned here is the first element, which is the max of 0 0, which is correct. This will return it to 0 1, which itself will have another recursive call, which is this L2, which is shallow max of array of mid plus 1 and end, where mid plus 1 itself is yeah, so that okay, so let me just think. So it is it has gone to 0 0, it has returned it, and it has gone to the caller, which was 0 1. So it will call it with 1 1 now, and that will return the maximum again, which is array of start, which will be 1. Finally between 0, so now you are going to compare it between 0 and 1 and return the max out of that. So this is how it is going to execute for this version of the implementation. So are there questions about this version? Okay, so now coming to this, what I have done just to show you is that I have written these two shallow max and deep max, and remember the deep max is the one which takes one element, finds the finds the maximum in the n-1 and continues. The shallow max is the one which is going to break the array into two parts, find the max in the left, find the max in the right, and compare the two and return. So these are the two versions of finding the max. I have just implemented them and called them from min. So just to make sure that these are correct, what we will do is we'll compile them, and the array has been initialized to just array of I is equal to I could have done random and so on, but then we need to find out. This in fact happens to be a sorted array, so there is no need to find max in this, but I mean, there's no need to write such a complicated procedure to find max, but this is only for illustration. So I'm going to do this. Sorry, so there is no such file or directory. I think I have not gone inside the interface. Okay, so we'll ignore this warning about the return type of main, and I'm just going to execute this. So of course the answer, I mean, it's not surprising that the answer is 7 for both of them. So shallow max returns 7, deep max also returns 7. So do you want me to print out anything about the indices? You can print out the start index, end index. If somebody is interested in understanding anything more, I can print out things and show. So please let me know. Otherwise, I have something else to illustrate also. Okay, so what I'm going to do is I'm going to copy this code into the visualizer. Yeah. Okay, so this visualizer is something that we have seen earlier. We know that this allows us to visualize this code. And what I'm going to do is I'm going to only run initially let's say we'll run only the shallow max, that is or maybe only the deep max to begin with, and then we will run shallow max. Okay, so let's run this. Yeah, so I hope it is visible, Kaushal.
Yes, ma'am.
Okay, so so this you're familiar with this, that on the left hand side, or sorry, on the right hand side, you see whatever is happening on the execution on the function stack that is being built. The main is the function which is currently active, and that is the stack of the function main. And now when you go to this, of course, it will do some basic initialization of the array, which we will show. So this is going to initialize. I'm going quickly over it. It is Please note that it is initializing the elements of the array and the variable I is being incremented appropriately. Note that as soon as we quit the for loop, the I variable will go away because it has gone out of scope. So that is something that is not available to us now. So somebody had asked that, okay, if I store the pointer to it and keep accessing it, yes, you are accessing that memory location which is here, but that is not something which is valid. So anyway, that is out of the current context. Now we are calling the deep max, which remember it is doing, taking out the first element, looking at the max of the remaining, which are n minus 1, and doing it repeatedly. So I just want you to observe how deep the calls go. So that is why it is called as deep max. So it is called with array start and end. Array will always point to the first location of the array in the main, because we know that it is address, and the start and end are 0 and 7, which are copied, which is called by value. Again, array is also called by value, but it is only the address. The next one that we will do is L is equal to deep max of something. So we have given space for L, but we don't know the answer for L. So now it is going to call deep max, and this is the next execution or next invocation of deep max, which has been shown here. So the active one, which is the one in blue, so it is again calling with array start and end, and those start and end will soon be initialized, and they are 1 and 7, right? So remember that we have taken out one element, and we are doing this. We will keep doing this, and I'm going to go a little fast because it is going to take a while, because the array has a large this thing. So as you see that now it is called with 4 and 7. Finally, when it is called with 7 and 7, it is going to return. So I'm going to just, finally it is called with start is equal to 7 and end is equal to 7. So we have a deep stack that has been created with the repeated recursive calls, and that is why I have called this deep max. So I hope everybody sees this. The array will always point to the array in the main that has been allocated. These are the recursive calls for deep max, and this is the last one where start is equal to end, which is going to return to this place, which is the caller of deep max, which I am highlighting. It will return it to this, and so on. So let's see this return value. Let's see this next here. So are there questions about this still here? Okay, so now when I do this next, it is going to return it to here. So you can see that the last one has gone away, and it has returned it to the 6, 7, and the max, the L value has been initialized appropriately to 7. Now, if you do further, it will initialize here and so on. So I'm going to just skip this by quickly doing this as this is to the last. Okay, so are there any questions or comments here? I hope this clarifies the questions that Satyajit, Kannikeshwar, or Chinmay had raised about what is the value of L that is returned and so on. Okay, can you show the next step after this? Sure. Thank you for telling me now. Okay, yeah, so I'm going to just do the next here. And as you see the next step, okay, so this is, I think it is still in that call of 6 to 7. So it was going to return, and I'll just do one more step. So that call will, that call will end. And now you see that from 5 to 7, it has returned the max as 7. Is that okay? I don't remember who asked me. Shashank, I think. Okay, so I'll assume that this execution is clear. I have forgotten to post this link. I will quickly post this link in the chat so that you all can visualize this whenever you want to. And okay, okay, so I'm not seeing the chat messages, so I don't know what people are writing in the chat. Yeah, so I have sent this link to the visualizer. Please visualize it at your pace and check it out. So in the interest of time, I will not visualize the shallow one. You can see that the shallow one won't go ever as deep as 7 because it will be shallow. It will break it down into smaller parts, and therefore the maximum depth will be 4 at any point of time for an array of size 7, array of size 8. So actually not even 4, it should be 3, but with the main it will be one more. So please visualize that at your pace. I'm not going to show that part, but what I'm going to show you is one thing that let's now see this execution on a slightly larger instance. So we have this, of course, I'm not going to visualize it on a large instance, but let's see the execution on an instance of size, let's say. Yeah, so let's see what happens if you, okay. So one thing that I have not explicitly mentioned, we have never said this, is this hash defined size is something. So we'll come to that at some later point, but this just says that I can take this wherever size occurs, it will be replaced by whatever value I have written here. This need not be a value, it can be anything that you can write here, and it will be replaced. It is in fact a pre-processing step even before the compiler starts executing. This is called a preprocessor directive, which is this hash define. We'll come to that, but that is slightly out of context right now. Okay, so again we get this warning, and if you run this, you will, I hope you are able to see that shallow max does give you the answer correctly, which is the largest element in the array. However, deep max gets a segmentation fault because the depth of the recursion has gone so high that you have run out of stack space, and therefore this is something that shows you that the recursive version where you have divided into 2 parts is better than the recursive version where you have divided into n-1 and 1. Although the number of comparisons in both of them remain the same, the recursive depth of the stack is much larger in the first version, which we called as the deep max, whereas it is much smaller in the second version, which is shallow max. Okay, so this is what I wanted to illustrate using this. Yeah, are there any questions? So Shwetika, I can see that you are talking, but I can't hear you. No, I am unable to hear you. So Shwetika, I request you to please type out the message on the chat. I will look at it. So Kaushal, are you able to hear her?
No, ma'am. Very quite low. Her voice is quite low, actually.
Yeah, I can only hear that she's speaking and see that she's speaking. Okay, so are there any questions before I move my share screen to the slides back again? So Shwetika has a question. I don't know whether she's typing it out. Okay, I think I'll move to the slide sharing mode again and stop this sharing. Okay. Okay, good. So okay, so the exact versions that we have implemented are slightly different because they take in the array as a parameter, but nevertheless that should not bother you. As long as you keep the array as global in these implementations, they are exactly the same. Okay, so let's move on to the problem that you were given, which is this which was in the yesterday's lab, printing an array from left to right. So I hope all of you got it. In fact, you had another question, printing the array from right to left. But I want to illustrate one point here. So I would expect most of you wrote code which looks similar to this, which is print it from left to right. It takes an array as a parameter. It takes start and end indices of the array. In fact, we did it in the class itself. So if start is less than or equal to end, then you will have to do something. So therefore, you print the first element of the array, which is a of start, and then you call this print L2R with the same array parameter, and then do start plus 1 to end, right? So this is something that most of you would have written. You may have written it into multiple cases, but doesn't matter. It should be a program which looks almost similar to this. Any questions or comments here? Okay, so what I want you to think about is this implementation 2, which has a different set of parameters. It takes the array, it takes this array which is the same array that we are interested in, and the second is not the start and end, but the number of elements that you want to print in the array, right? So n is not the index, it is the number of elements into the array. So this, if you have an 10 sized array, you will send the starting location of the array and 10, which is telling us that we have to print 10 elements in the array. So I have given you some template. I would like you to fill in what will you write it here, just like what we do in the exams. If n is equal to 0, return. I want to bring out that this return says that do not do anything and just return this call. So it won't be doing anything. So if n is equal to 0, there is nothing to print in the array, therefore return. Else, what should we do, and what should this print L2R with the two parameters be called with? So please write your answers in the chat. Okay, so I see suddenly people leaving the meeting. I don't know, is there any reason?
Ma'am, is there an else before printf?
Okay, so what I'm wanting to tell you is that the else is not required. I mean, you can write an else, but it is not required, because if n is equal to 0, it is simply going to return from this function. So there is, I mean, it will come to this only if n is greater than 0. And remember, we should take care of calling it when n is greater than 0 always. Is it clear, Kannikeshwar?
Yes, ma'am.
Okay, sure. So yeah, can people say what has to be? Okay, so the first thing that you need to write is what has to be printed. So let's take answers one by one. So let's fill in the blank, which is this printf %d, what should be printed? Okay, I see some answers which are correct. Good. But very few, I mean, only 2 or 3 have even answered. So remember, okay, so Shashank, you are asking, right? For n is equal to 0, we have the index 0 element. Why are we not printing that? Remember, I'm not saying that n is the index into the array. It is the number of elements in the array that we want to print. So we are not saying that we want to print the index element 0 or n. It is we are wanting to print 0 element. Okay, so Kaushal, can you hear me? I see some network issues.
Yes, ma'am.
Okay,
I
fine.
can hear you.
Okay, sure. Okay, so this printf, remember that if we have come here, it is the duty of the caller to ensure that it is always sent with n greater than or equal to 0. If it is equal to 0, we would have not come to this printf statement. So if we have come to the printf statement, we simply want to print the element at the 0th index. So we are going to print the element at the 0th index, which is ARR of 0. And if so after we have printed the element at ARR of 0, we want to print the remaining array. Remember that we are sending the array location, which is as good as sending the pointer to the first element. So now we want to start printing the array from the second element, which is indexed at 1 in C. But we will say this ARR plus 1, just like what we did in case of string length. And then with the array starting at ARR plus 1, you want to print only n minus 1 elements. Therefore, the next parameter that is there is n minus 1. And this keeps decreasing. That is why at some point you are going to reach a place where you are going to print 0. And at that place, you should not do anything and not print out and just return from that call. So, is this code clear? I mean, I think most of you would have written code which resembles the first implementation, which is fine. These two implementations are exactly the same. And you will see that writing recursive code for print is not the best way to do, because it unnecessarily creates these multiple recursive calls, and iterative print is the best thing to do. However, this is only to illustrate or exercise our thinking of recursive programming and recursively writing code with simple examples that we know how to do already iteratively. So any questions or comments here? Okay, and I wanted to show this code running on the visualizer to show you that the repeated calls that are there to L2R change the pointer into the original array. I will leave that visualization to be done for you offline. So I won't show that here in the interest of time. Okay, so Satyajit is saying that for me, the first program was giving a warning. So I don't know what warning, Satyajit. You have to send me the program. If you send me the program, I will look at it, because I don't know what warning it is and what program have you written exactly. Yeah. Okay. So I just want to, you have done this again in the last lab, but in yesterday's lab, but I want to show that just one change in the way the program is written, the function is written, will change it from left to right to left. And you could have called it left to right, but doesn't matter. It is going to print it from right to left. In fact, you just call it print array and it is going to print it either in the reverse way or the correct way, left to right. So by just calling the print function first and then printing ARR of 0, contrast this with print left to right, which was here, where we printed the element first and then called the recursive function print left to right. We are doing it the other way, which will make it a reverse printed array, which will make the function print the array in the reverse way, which is what was the second question that was asked. Again, the first implementation can also be modified in the same way. So I think you must have done one of them to get the answers. If you have not done it, I feel sad because I have already given you the answers now, but you should have tried it ahead of time. Okay, any questions, comments here? Yes.
Yes, ma'am. As we do this, once n reaches 0, ma'am, it will come out of the function now. It will come out of the function now because we have a return in its statement. Or will it be going to the next previous function call, ma'am?
Yeah, note that it will return to the caller of that print L2R. It will return to the place to whoever has called that L2R or R2L in this case, right? So what do you mean by it will return? It will remove that stack frame which was created for that execution. Remember that when we did that shallow max or deep max, then you saw that there were several frames of shallow max which were created with different parameters. So the last one is going to be created with some parameter of the array and the integer 0, and that will return to the one which was calling it, which should have been with an array parameter, which was a particular array parameter with n is equal to 1, right? That is the place where it will return, and that is going to execute, and that itself would have called it, which will execute this printf %d array of 0 for that call. Is it clear? So it returns, meaning it returns to the caller.
Okay, ma'am.
Yeah. So again, I encourage you strongly to visualize this on the visualizer with completing the code with the main, etc., with an array of size 5 or 6 or something, which is manageable for you to visualize. Okay. So I'm going to move to the next example that we have. Are there any questions about this print? Okay. So the next example that we have is recursively searching in a sorted array. And we have seen this already. We have seen that binary search is something that we should be doing, which does fewer comparisons than the linear search. So linear search is always possible, which is what is the first recursive thinking, although it is an inefficient recursive implementation, because it will, if you take out the last element and check if it is equal to the key last or first element, and check it if it is equal to key, else search in the first remaining n-1 elements recursively. This will always search all the elements, and it is not making use of the fact that it is a sorted array. This recursive thinking can also be used for an unsorted array. However, the correct way to think about it recursively when it is a sorted array is to divide it into two parts, just like we did for max, and check if the element is less than the middle element. So again, sorry about this, that this then it is search in the left part of the array. This is incorrect for our way of sorting, because we have always said that the array is sorted from in decreasing order. So if it is less, then we will search in the right part of the array, else we'll search in the left part of the array. I'll correct this in the slides when I post it. But we are going to write the searching for an element in a in an array which is sorted in decreasing order. So this is our goal. We have an array which is sorted in decreasing order or non-increasing order. We are given this element which we want to search, and that is what we want to this is something that we are going to search. Okay, so I see, and this thing, we have a midsem starting at 9:50. Okay, so okay, so I can in fact stop the class if people want to go. That is why I see that there is such a small attendance today. Okay, so people want to leave, then I can just stop the class and post the slides for binary search, and you can look at it. Okay, I'm just going to stop the class now. I'll post these slides. You can look at the binary search. We'll meet at 2 o'clock for the lab. Okay, thank you for telling me, one of you, Arjun or somebody who told me. Okay. I wish you had told me earlier. I would have moved the class to some other time. Okay.